Well, at least you apologize for that.
All right, are we listening? I just said earlier that my board looks like someone threw up on it, on these two boards, right? Okay. I'm going to teach it to the way I just taught those two who were not here previously. And I think it really hit home with them because they were trying to figure out which rule it was first, and I focused on that rule and only did it a piece by piece. I think it'll help you guys too. So I'm going to quickly do a couple problems, which I have to anyway because I'm going to do interval notation. So it's going to be a great transition to it. So are we ready?
Should I just press down like this homework lesson?
Yes and no.
Should we write this down?
Yes, you should write down what I have on the smart board, not this. I'm going to refer to rule 1, rule 2, rule 3, rule 4. Okay?
So we don't have to write this down.
Rule 1 is whenever it's the numerator, you already have it written down. Rule 1 is the numerator rule. Whenever x is in the numerator, you have no restrictions, right? Rule 2 is the denominator rule. And I squiggly lined that because I wanted you to see that if you would rearrange the m to n, it spells even.
Wow.
No, that's kind of a cool thing to think about because it's in the denominator, which means it's an even, which means it can't equal 0, right? Right? It's an even denominator, okay? So now, the next one, number 3, is the odd roots. There are no restrictions with odd roots. Yay, nay? Yeah. And my last rule that I want you to remember is the even roots have to be greater than or equal to 0. So we are literally going to refer to rule 1, 2, 3, or 4 today. Yes? Okay. So, my first example. F of x is equal to 3x minus 9. These are chapter 1-3. 3x minus 9. I'm going to kill domain because it's very, very, very important. Okay? So what is my domain of this thing? 3x minus 9. What rule am I? What? Nigel? X is not on the reals. Why? Why is X is not on the reals? Because it's rule number 1. It's in the numerator. Because I don't have a fraction. Since I don't have a fraction, that means it's in the numerator automatically. Yes? Yes? Okay. Next example. F of x is equal to 3x over 5x minus 9. What rule? What rule is it? It is rule 2. And what does rule 2 tell us about? Rule number 2 is your demon rule. I better go fraction rule. Demon is very nice. It's your fraction rule, and it deals with your demon denominator, right? So with that said, what can it be? 5x minus 9 cannot equal 0, so 5x cannot equal 9, so x cannot equal 9/5. Yes? So what do I do then? Gotta give it a family. It's lonesome without a family, right? And what is its family? X is an element of the reals. It belongs in the real number family. It needs to have a family. If it doesn't have a family, it cries. Okay? Do we understand that? Yes? Moving smirkily along. The cube root of x equals 7 over 15x plus 13. What rules do I have? I have rule 2 and rule 3. So rule 3 is the really easy one. This is my odd roots. And what do I know about my odd roots? No restrictions, so therefore it is going to be x is an element of reals for that one because there's no restrictions. Yes? There's no restrictions. I'm good to go. Okay, so what's my next rule? Rule number 2, which is the fraction rule. So if it's the fraction rule, it's my demon denominator. Yes? What's that going to be? 15x plus 3 cannot equal 0, so 15x cannot equal negative 13, so x cannot equal negative 13 over 15. So what's my actual domain? Slap them together. X is the number of the reals. X cannot equal negative 13 over 15. We getting it? We getting it? Oh,
Can we do one
oh, I'm about to.
Range.
Don't steal my thunder yet, guys.
We're not there yet.
Okay. F of x is equal to square root of 6 minus x over 3 plus 4x. Rules do I have? 2 and 4. Is the rule thing helping today? Yay. Rule number 2 is my Beeman fraction rule. So what's my Beeman fraction rule say? Three plus 4x cannot equal 0. So 4x cannot equal negative 3. X cannot equal negative 3 fourths. Okay?
Yay.
Demon? Yay? My demon fraction? What is my next one? Rule number 4, which is my even root. So if I have my even root, what's that saying? That means that the junk inside the root has to be greater than or equal to 0. So what does x have to be greater than or equal of? Always. Subtract the 6. And I'm just doing this way to remind you of something I normally would not. I'm dividing by -1. So when you divide by -1, what must you do? Flip it, jump the signage. Yes? Okay. So now, I have those two boxes. So what's my actual domain? X is the noun of the reals. X cannot equal negative 3 fourths. And x is less than or equal to 6. Yes, because it's a family. We are family.
So you always have to put that X.
Yes, you gotta say what family it belongs to. If you don't tell it what family it belongs to, it says it runs around and says, do I belong to you? Do I belong to you? Do I belong to you? And it bounces off back and forth. Okay, you have to say that it's part of the real number system, the imaginary number system, an integer number system, a natural number system. You have to say where it belongs. Okay? If you don't, it's homeless. I mean, no one likes homeless.
Live in a box.
Live in a box. It does live in a box.
Like it don't.
It really does live in a box, right here. Don't you love it? Lives in a box. I love that part. Okay, do we understand? Okay. Do we feel like we understand more than what we did previously? Yes? Is it like clear as mud? Is it clear as a creek water? Is it clear as water coming out of your faucet? It is creek water.
Yeah,
That makes
just like
sense.
it was yesterday.
Mine's about as clear as water after.
Kind of like our.
Can I get it? Oh, we did that one. That one you're not going to be responsible. Okay. Now, with that said, we talked about this yesterday. These are still in your notes, okay? Today what we're talking about, this is already in your notes. Any of you already copied it down. There's no need to redo it, but do listen by putting down your IDs and stop playing with them. Okay? Now, domain are all the x values. You read it from which direction? Left to right. Now, whenever I say read something from left to right, I want you to consider yourself to be this little train or car. Check it, check it, check it, check. And what you're doing is you're still looking straight ahead. You're looking somewhere in there. Is there a graph? Because I'm this x value, okay? I am that train on the track, okay? And my train has to correspond to a level little y value somewhere. Does that make sense? So you're looking for that y value, that x, because you're that train, you're x. What does it correspond to? Does it correspond to a y above you, or does it correspond to a y below you? Okay? Because you're reading from left to right. You're still checking. You're looking for each x value. Does it have a y value? Is there a missing y value there? That is domain. Range, however, is your y values, which means you're kind of like, what's that thing you jump on? Not a trampoline, a pogo stick, right? A pogo stick. You start at the bottom, and you jump all the way up to the top, right? We're looking for our corresponding x value. We're looking for that corresponding x value. So way down here at the bottom, whenever I look up, where can I see the graph? Okay? Does that make sense? I want to find the absolute smallest y value that corresponds to an x, and then I want to go to the largest possible y value that corresponds to an x. Does everybody understand what range is? Okay. Now, did you guys copy these down yesterday?
Yeah.
Not all of them?
Yeah.
Okay. Now, these two right here, infinity is the absolute largest number in the entire universe. Okay? Nothing is larger than infinity. The smallest number is negative infinity. Nothing is smaller than negative infinity. Y'all with me? Okay. The next thing you need to understand are these two little closed dot and open dot. An open dot is on the graph. They're on a graph, always on a graph, okay? Because on a graph, whenever you have an open dot, it means there's a hole there, and that means there's no x. That x value, there's a hole on that specific x value. It does not have a corresponding y value. That makes sense? When you have a closed hole, that means that is an actual point on the line, and it is included in that graph. Everybody with me? Open dot, it's excluded. Closed dot means it's included. Get it? You got it? You're confused? For example, if I was graphing something right here, and I put an open dot here, that means that it excludes that point right there. There's a hole. No, there's a hole. Okay? And this is like it. I know. Okay, we good now? The closed dot means part of that line. It's a corresponding dot on that line. Does that make sense? So point. All right? Now, this is interval notation. The brackets mean it's includes the value at the end, and the parentheses means it's excluded. This is for interval notation. This is for interval notation. Okay? Very, very important. And the last one, you never, ever close infinity with a bracket. Because as soon as you close infinity with a bracket, what that means is it no longer has any bigger numbers in that. Do we get that, yes or no? Okay? what we're going to do is we're going to go back to all those examples that we just did in class, and we did the domain, and we're going to put that in interval notation so that you can see us write in interval notation. Is everybody ready? Are you ready now? Thumbs up, side, go on. Okay. Here we go. How do I put in interval notation X is down to the reals? You gave me that domain. Now, if I'm in interval notation, I'm going to ask myself, what's the smallest possible number this can be? If it's known to the reals, what's the smallest number it can be? Negative infinity. So I'm going to change my pen color here. I want you guys to be able to see this. And it didn't change, but okay. It's from negative infinity to infinity. Okay, what about this one? X is an element of the reals. X cannot be 9 over 5. What's the smallest value it can be? Negative infinity. So I start at negative infinity. I close my parenthesis. And where do I have a hole? What can it not be? It can't be 9/5. So at 9/5, can I include 9/5? Because it's not allowed to be it. So do I have a bracket or do I have a parenthesis? Bracket means I'm including it. Can I include it? No, so I have a parenthesis. However, I stopped there, my interval. So now I have to put a U, because U means union. Union means and. Remember, and. And then we're going to start it again, right at 9/5, because we're excluding it. And then how far up can it be? Positive infinity. And I close it with a parenthesis because it cannot be bigger than that. Yes? Okay, let's go to the next one. What's this say? What's the smallest number it can be? Negative infinity. So I put a parenthesis, negative infinity. Comma. Where's my hole? Negative 13 over 15. Can it be negative 13 over 15? No. So is it bracket or parenthesis? Parenthesis. And is that as large as it can be? No. So what do I do to put more? A U. And where does it start again? Parenthesis negative 13 over 15, comma. And what's as big of the number it can be? It says X is an element of the reals. It's excluding negative 13 over 15, so it goes all the way to infinity. Now, that's not as nice a notation, is it? Because you got two of them that you got to write. Okay? This one's going to be fun. X is an element of the reals. X cannot equal negative 3/4, and X has to be less than or equal to 6. So what's the smallest number? Negative infinity. Okay? Do I have any holes? Negative 3/4. So I stop at negative 3/4. Can it be it? No. So open or closed? Open or closed? Open. It cannot be it, which means it's parentheses, right? Union. I start again at negative 3/4, comma, and then how big can it be? Can it be 6? So if it can be 6, what does that mean? What? Closed, which is what? Bracket or parentheses? Bracket. Do we understand that? It's something new. I have to introduce it to you so that you can see how we use it, okay? All right, that is interval notation. With that said, let's start tonight's homework. This is number 1. This is number 1 from the 1 through 20 that I didn't get to teach yesterday. The 1 through 15, 1 through 16, sorry. 1 through 16. Okay, this looks like the graph on there, right? Something like it. Not exactly. I just put a U up there, upside down. Okay, now, domain. How do I read domain graphically? From left to right. So my domain is read from left to right. And as I am a train, I'm a car, right? And I am clear to the left at my smallest possible value in the world. What's my smallest possible value in the world? Negative infinity. As I chug along here, I ask myself, I'm this x value that's very, very large, that's negative. Do I have a corresponding y value? In other words, can I see the graph clear back here? I can, because the arms extend down to where? Clear into the floor, down into demon world, right? Yes? So is there a y value and an x value corresponding together down there? Yep, so I keep chugging along. I'm chugging along. I'm closer, landing within 10. I can see it, can I? Here I am. I can see it. I correspond to something down there. I correspond to something down there. I'm right here. I correspond. Up, I see something. I still see a value. I still see value. I still see value. Now my value's down there. Now my value's down there. So what does that mean? What's my domain? Do I have any holes? So what's my domain? Negative infinity to infinity. Meaning x is an element of the reals. Whichever one your brain can get. Okay? You with me? Now my range. Which direction do I read my range? From the bottom to the top. So I'm clear down here at the bottom, and I look up. As I look up, what am I looking for? The ceiling, which in this case, I'm looking for the ceiling of the what? The graph. I'm looking for the graph. So as I'm coming up from down at the bottom here, do I see an x value corresponding to a y value? Here it is. How about over here? Do I see it? I do. There it is. There it is. There it is. Up, I max out. There's nothing after that. I see the ceiling. I see the ceiling. So what's my lowest possible y value? And what's my highest possible y value? 1. Please, please, please make sure you're reading the y value, not the x value, because many people put 0 because it looks like it's at 0. Okay? The x value is 0, but the y value is 1, and it can be it. You understand? Because it is closed dotted there. It is allowed to be it. Okay? Now the next question says to do f at 0. Well, what do you normally read there? Not f at 0. You normally read f of x. So what you're telling me is I'm calculating, I'm plugging in 0 in for x, right? Which is the same thing as evaluating at 0. So what turned into 0? X. So here's x. Do I have a corresponding y value? Right there, what is it? It's the point 0, 1. So this is 1. At that 0 is 1. Let's do it again. Number 2. Number 2 has these lovely little points. I gotta try to draw them. It goes through this point. It goes through this point. It gets as high as negative 1, 4. And it comes down here. There's my graph for number 2. Yes? Okay, so I'm on my train. I go from left to right. What's my smallest value that x can be that has a corresponding y? Negative infinity. Okay, so now I get up here, my domain starts at negative infinity. Do I have y? Do I have the y value on my train here as I'm on the road here? You see it? Am I on it? Do I have any holes in it? No, there aren't any holes. Those are just points on the road, right? And how far does it go? To infinity. Okay, how about my range? How about my range? My lowest value is negative infinity. And what's my highest? Infinity. Those ones are great and easy. Now, what's it asking me to do? The last one I have to do is f at 0. So I go to the x-axis, right? Here's my x-axis, and there's a point on it. What is that point? The coordinates. 0, 2. So what's f at 0? 2. Do we understand how to do 1, 2, 3, and 4? Now, let's look at number 3. Here's your graph for number 3. What's that doing? I need the domain. So my domain starts where? Chugging along here. Where do I finally see a graph? I finally see a graph at negative 4. Can it be it? Yes. Close it. And where does it end at? It ends at positive 4. And it can be it. My range. Where does it start? It starts at 0 because look, I don't have any graph below 0, do I? I don't have any graph below 0. So therefore, I have starts at 0, and then where does it end? It ends at 4, and it can be that. Okay, so now what's the last thing that it's asking you to do? F at 0. So find your x-axis. And find that point right there, and what's the coordinates of that point? 0, 4, so it's going to be 4. Do we understand how to do that, yes or no? Okay, now, 5 through 10. It says, use a graphing utility to graph the function and estimate its domain and range, then find the domain and range algebraically. Domain algebraically is rule 1, rule 2, rule 3, rule 4. Does that make sense? Yes? Can we get that now? You're doing what you did, but you're going to graph it. For example, number 7. Number 7 is what? I can't hear you.
X minus 1.
Did you say negative root? Okay. All right. So now, what is my domain of this thing? What rule is it? It's rule 4, right? So if this is rule 4, that's going to be my even root rule, which means x minus 1 has to be greater than or equal to 0, right? So therefore, what is that? X is greater than or equal to 1. X is an element of the reals. Right? Okay, so now what they want you to do is to graph that. So if we graph this, calculator page, and I'm graphing the square root, and what was it, x minus 1?
Yeah.
And hit enter. Does that match? Does my domain match that it has to be greater than 1? So that means I did my math right. Do we see that? Now what is my range? What's my range? 0 to infinity. Do we all understand that it started at 0 and then it shoots off in one little arm all the way, okay, to infinity? So therefore, my range is going to be from 0 to infinity. And this is going to be from 1 to infinity. Do we see that? Any questions on that? The range, you look at the graph. So you can't do the range algebraically. Not yet. Okay? The range, you're going to look at the graph, you're going to go from, do you not understand how to read the graph on that one? Okay. Okay. You're coming up along here, and where does it start at? The first place I see from the bottom up is the point 0 here, right? And then, you see I have y that I use all the way across here? As I get higher and higher and higher, it's going to be an arm clear out there. So it starts at 0 and then it ends at infinity. Does that make sense? Read it from bottom to top. Okay? Okay, so now, do we understand how to do 5 through 10? Now the last little tidbit that you need to know about is the vertical line test. Vertical line test. This is a test to see the function is a function from y to x. What this means is very easy. You guys learned this from Algebra 1. I know you did. My Algebra 2ers learned it last year. Okay? If the vertical line intersects the graph more than once, then it is not a function. For example, I give you my spaghetti function up here. What does spaghetti function look like? X cubed, right? X cubed looks like spaghetti. If I draw a vertical line there, how many times did it cross it? Is it a function so far? How about now? Still a function. How about now? Still a function. So this one is a function, right? What about this one? No. Why? Because it intersected twice. Do we understand that? This is like 11 through 16. All you have to do is write yes or no. Okay? Any questions on tonight's homework 1 through 16? Are we good, David? Are you learning your calculator, David? I'm glad that you can use my class time to really figure out that calculator.
He already knows what he's doing.
He does.
Yeah,
I can't
like
complain.
these guys could all in.
He does. All right, are we good on tonight's homework? Tonight's homework is 1 through 16 all. Okay? Any questions?
That's